depending on the quadrant your terminal arm is in. For example, let's say my terminal arm is in quadrant 4. So my principal angle is always going to start from here and always go all the way around until it meets the terminal arm. So that is theta. So clearly theta is a really big number. It's obviously bigger than 270, but less than 360. It's probably like 300 degrees or something. Now your related acute angle, your beta, is from here to here. Beta, that's beta. So that's an example when your terminal arm is in quadrant 4. Well, what if your terminal arm is not in quadrant 4? What if your terminal arm is in quadrant 3? Let's say something like that. Well, now in this case, your principal angle is from here to here. It's obviously bigger than 180, but less than 270, so it's probably like 190 or something. But your related acute angle, your beta, is from the terminal arm to the nearest x-axis, which is from here to here, and that is your angle beta. Clearly, beta is not that big; it's kind of small. So it really, your beta depends on which quadrant your terminal arm is in. And in quadrant 1 is the only quadrant where your beta and your principal angle are exactly the same, because this is your principal angle from the terminal arm to the initial arm, and also it just happens to be from the terminal arm to the x-axis. They're the same. So quadrant 1 is very easy. It's you don't really have to do much math. They're both equal, those angles. So if you figure out one, you kind of figure out the other. So why is beta important? Beta is very important. It's actually kind of more important than the principal angle. Sort of, not really. The reason why beta is important is because we can solve for beta, and then we can use that information to solve for the principal angle, because the principal angle and beta have some kind of symmetry, you could say, between them. So let's do some examples, shall we? All right, so example 1, find the reference angle for each of the following principal angles. So reference angle is your beta. Okay, that's another word for beta. So related acute angle, reference angle, that's all beta. Principal angle is always theta. So the first thing I'm always going to do is when I draw my grid, I'm going to always label my key points of 0, 90, 180, 270. So I can, easily visualize which quadrant 250 degrees is going to be. So where's 250 going to be? Which quadrant is 250 going to be? I'm going to ask the class quickly. Quadrant 1, 2, 3, or 4. Angle 250. Where's it going to be? Anyone? Yay, good job, Henry. So 250 is going to be, yes, thank you, Atia. Perfect. So quadrant 3. It doesn't really matter where in quadrant 3, just kind of put it in the center, because it's just all relative. So this is angle 250 degrees. Now, what is the reference angle here? Remember, 250 is from here to here, but beta is always from the terminal arm to the x-axis. And where students make a mistake is sometimes, since the terminal arm is so close to the y-axis, they think that, oh, you know what? I'll just take the angle from here to here. That is the most incorrect thing you could do. I guarantee you some students are going to do this, but that is the most incorrect thing you can do. Please do not do that. That is absolutely wrong. The only right way is to always take it from the terminal arm to the x-axis. And that is your beta. Now, how do I figure out the actual value of beta? Well, I know that this is 250. How do I know this is 250? Well, they told us the principal angle is 250 degrees. I know that this green part here, from here to here, that's 180 degrees, because that's a straight line, right? And this blue part from here to here, that's actually the same as this red part, because they're going the same angle distance. So that means if I take the green part and I subtract it from my blue angle, which is 250. If I do 250 minus 180, I will get 70 degrees. That means my beta is 70 degrees. Hopefully you guys can see that. So remember, the whole thing here is 250 degrees. From here to here is 180. So if I subtract 250 and 180, what's left over is this leftover red part, and that is your beta. So you just have to subtract your principal angle and 180, and you get your related acute angle. But remember, your related acute angle depends on the quadrant it's in. So for example, B, or question B rather, your related acute angle, you may not have to subtract 180. Let's see if that's the case. So first things first, always label your points. And then draw your terminal arm. So a terminal arm is of 120 degrees. So 120 is obviously bigger than 90, less than 180. So it's going to be somewhere here in the second quadrant. And now my principal angle is from here to here. That's 120 degrees. My related acute angle is, remember, it's always from the terminal arm to the x-axis. Now here, I can't do 120 minus 180. That'll give me a negative answer. It doesn't make any sense. But guess what? You know what I can do? If you look at the lines, 120 goes up to here, and then the red part goes up to here. If I add the red line and the blue line, I'm going to get an angle of 180. So 120 plus my related acute angle is equal to 180 degrees, right? So what I can do is related acute angle is actually 180 minus 120, 60 degrees. So instead of principal angle minus 180, in this case, we're doing 180 minus the principal angle. So it really depends on the quadrant you're in to figure out your related acute angle. You can just use common sense too. You can just like draw diagrams and be like, hey, you know what? If I add this together, it's 180. If I subtract from 180, I'll probably get the remainder, which is 60 degrees. So this is 60 degrees, the red one. And that makes sense. 120 and 160, if I add them together, I do get 180. It makes sense. So that is how you do it. I would recommend you guys to practice this yourselves. I do have to do this. Yeah, so the next two you guys will have to do on your own. I'm going to quickly do this. I won't get the chance to do my thing that I always do because we only have less than an hour now. Okay. I'll do my best. So when we are drawing on a grid, right? So X and Y, remember, they're points as well. Like if I take a Cartesian plane, let's just put some points. Let's say, I don't know, 5 here, 5 here, -5, -5. All right, let's just say these are some points. Let's just pick a random point. I don't know, here. Not 5 and 5. Let's do like 6 and 5 or something. Let's say that point is 5, comma, maybe 7. All right. Let's say we have a point 5, 7. X value is 5, Y value is 7. So because it's on a grid, and this point, if I were to draw a terminal arm to that point, I can draw a triangle like this. And then I can draw an angle in that triangle. And this angle, or this triangle rather, sorry, has side lengths. And we know the side lengths. How do we know the side lengths? Well, easy. I know the distance from here to here is 5. Common sense. Because this is 0, and this point is 5. So from 0 to 5, obviously this is 5. I know the height is going to be 7. because I know that this point is 7.